Not only such a field of the production of antihypertensives, but other fields they use. For example, Novartis, they produce the anti-cancer drugs by using coupling reaction. This one or this one. Using such a coupling reaction, G-spot and G-spot. Next slide, please. And also other companies, for example, the drug for anti-HIV medicine, Novartis produced this compound, and also this is also vancomycin. That is also, of course, as you know, very useful. This compound, the medicine made by the American Eli Lilly in Indianapolis. They produce this compound. In this case, coupled this part and this part, and this is also. Therefore, in many fields in the pharmaceutical industry, our coupling reaction using aromatic folic acid and the aromatic halide used for the production of such a target product. Next slide, please. Not only in the pharmaceutical industry, in the agrochemical industry, for example, in the German BASF company, produce this phosphorite. This is a very effective agrochemical. First company first produced this compound, starting from this. In this case, they produce this compound from this. Then they obtain this compound. But in this case, in order to obtain this product, they need 5 synthetic steps. Therefore, this overall yield based on this is very, very small. So finally, BASF company changed the synthetic method of this compound, not from this. It says that they use our cross-coupling reaction of this phenyl chloride and the phenylboric acid. In this reaction, they obtain this compound only one step in very high productivity. Therefore, recently, the BASF company only produced this compound through this route. Next slide, please. Last September, I had a chance to visit the Brasilia in Brazil to attend the international conference. On my way back from there, I stopped over at São Paulo in Brazil. The people there in Brazil, they told me, the BASF company, German BASF company, produced such a big plant near the São Paulo. I never visited there, but this is such a plant. By this plant, they produce this compound to this. Anyway, in the industry, in the pharmaceutical industry, they produce very complicated structured compound. But the amount is very small. But in the case of agrochemical, amount is so big. I don't know how many pounds, hundreds, thousand pounds, but anyway, so big amount of the agrochemical made by using our cross-coupling reaction. Next slide, please. Not only such in the pharmaceutical and the agrochemical industries, recently many industries applied our cross-coupling reaction to produce the biphenyl type of compound. For example, the some company produce the important chemicals for liquid crystal. For example, in Japan, chip company, and in Germany, milk company. German milk and American milk is a different company. Anyway, such two companies produce almost the majority of such materials necessary liquid crystal. I don't know exactly, but people say almost 49% of such liquid crystal made by Chisu company in Japan, and 50% made by German milk. Only 1% many other other countries. But anyway, the company produced the majority of liquid crystals. In the case of Chisu company in Japan, they produced this compound as a liquid crystal. By this reaction, they tried the coupling reaction, this formic acid, this aromatic iodide, and our condition to give this. Similarly, Merck company produced this compound and this compound. They produced so many, thousands different kinds of such a product produced. Next slide, please. And also recently, some of the chemical industry produce the necessary product for organic LED materials. For example, in Japan, Idemis company produced this compound, a cross-coupling reaction between this blue part and this red part by using our cross-coupling reaction. This is similarly in Japan's Toso chemical industry produces this compound by same type of reaction. Next slide, please. And also, most recently, the Sumitomo Chemical Company people told me recently, their company, Sumitomo Chemical Industry, they produce such a polymer type materials for organic LED product. That is this kind of pattern. That is also very big advantage. So maybe in the near future they use this reaction for the application of such a oil in the compound. Next slide, please. I think today, as I told you, I told a little bit about the coupling reaction, this one and this one, or this one and this one, and this one and this one, this one and this one. But as you can see here, we can use many different kinds of the combination between the organoborane compound and organic hair. So we have so many different type of application for our coupling reaction. Next slide, please. It is 6 hours. We have 4 more time. So here I show you the advantage of our cross-coupling reaction. As you can see here, we can readily obtain necessary organoborane compound by using a hydroboration reaction or transmetallation reaction. Second, our reaction proceeds under mild reaction condition. Today, I never told you a little bit about the base problem. As I told you in previously, in your coupling reaction, we need a base. Without a base, no reaction occurs. On the other hand, we have many organic compounds which are sensitive towards the base. In such a case, we may have some problem. But today, I don't have any time, so I never told you. But fortunately, by applying the modified reaction condition, using the solvent system, or using the base, we can overcome such a difficulty. So we don't have any problem. And also, one of different characteristics, our coupling reaction is very stable for water. That is also one big advantage, because when, of course, as you know, when we use the organometallic compound, organometallic compound is usually very reactive, but therefore we don't never use any amount of the water. Of course, as you know, in the Grignard reaction, Grignard reaction is very, very interesting, but that is very sensitive towards water. And secondly, in the solvent, we often use ethylene solvent, GH ether or THF. But in such an ethylene solvent, if we have a small amount of water, Grignard reagent immediately broken. Similarly, organo zinc compound, organo lithium compound, organoaluminum compound, all of such organometal compounds is very sensitive towards water. On the other hand, organoborane compound is very thick. That is very big advantage. And also, we can use our coupling reaction in the aqueous soluble condition or heterogeneous condition. And also, we can use many different kinds of organic compounds, which has many different functionalities. On the other hand, when we use other organometal compounds, such as linear reagent or organo-leaching compound, organo-G compound, if our reactant containing carbonyl group, such as ester, ketone, aldehyde, we never use. But in our case, our organoborane compound, no reaction with such a function. And also, our reaction proceeds to give expected product with radio and high radio and stereoselectivity. And also, our coupling reaction is not sensitive towards steric hindrance. Of course, we have to consider such a steric hindrance even in our cross coupling reaction, but not so sensitive compared with other usual organic reaction. And also, we need the catalyst. Without the catalyst, today I don't have any time, but in our reaction, we need the catalyst. We usually use the palladium, but not only the palladium. Recently, many people use the nickel catalyst, and recently, the Professor Nakamura in Kyoto University, they discovered the iron as a catalyst. But according to my opinion, at this moment, palladium is still best the catalyst in our cross-coupling. But anyway, we need a catalyst, but amount is very, very small. That is also very big advantage. And also, as I told you previously, we can apply our coupling reaction as one-pot synthetic method. And also, since I told you, our coupling reaction is non-toxic. That is also very big advantage. Of course, some of people know as a cross-coupling reaction using organometallic compound, we can use organotin compound. This is called as Steele coupling reaction. Professor Steele is one of my close friends, but unfortunately, pretty long years ago, he passed away by the accident at the Chicago O'Hare Airport. But anyway, Steele coupling reaction, they use organotin compound. That is very nice reaction. But unfortunately, organotin compound is very, very toxic, of course, as you know. Therefore, no pharmaceutical industry, they don't want to use such a toxic organotin compound. But organoborane compound is very not toxic. And also, finally, if you want to remove the boron compound, that is very easy because end of the reaction, they oxidize the reactant by using alkaline hydrogen peroxide at room temperature. Short times, just stirring. Then the such as remained organoborane compound, the oxidized boronic acid, then just washing the reaction organic solvent with base, then we completely remove the boron component. Therefore, here in your slide, maybe I just added another one. This is the green chemistry. That is such a result is just important factor as a green chemistry. Therefore, I think it's almost time to stop our time. But finally, I ask you if you feel interest in this coupling reaction, and in the near future, if you had a chance to use our coupling reaction for the synthesis of your target